So this is the waveform. Now how does this give us the advantage? Now what is the advantage? The advantage is this. Its output is independent of passive components. This is the advantage which we would like to prove. And first job of A to D converter is done. Now what is that? Voltage to time conversion. Voltage to time conversion. Remember, x axis is time. So if we change the analog input, time is changing. So first job is over. Correct. So it can be used as A to D converter, and we would like to check how the advantage is there. So for that, what we have to do is we have to write some equations. So to write the equation, we will start from a very basic equation. So let me rub out some of the things. So very basic equation is Q is equal to CV. Everybody knows this. Taking derivative of this is dq by dt is equal to C dV by dt. dq by dt is current, C dV by dt. Correct. Now we make two parts of this waveform. One is this part and the other one is this part. Second part. And both waveforms have the same voltage at this point. Both waveforms have the same voltage at this point immediately after t. So how do we write equation for this? So can we write the value of I? Remember, I is V input by R. I is V input by R, because V input is connected here and the right hand side of the resistor is grounded. So current through R is decided only by V input, no other parameter. So it must be V input by R. So we replace this V input by R is equal to C dV by dt. Now what is T? dt? dt is actually capital T. dt is capital T. So we write dV is equal to, what shall I write? dV is equal to V input by RC into capital T. This is equation number 1. Now we do similar treatment for the second part of this waveform. Now in this second part, what happens is the reference voltage is connected to the input. So we start from the same equation again. So let me rub out this part now and start from the same equation. So what is that equation? Q is equal to CV. Then dq by dt is equal to C dV by dt. C dV by dt. Then this is I is equal to C dV. Now t is different, dt is different now. So I call it as a maybe Tx or T2. I will call it as a Tx. So dV by Tx. Now I is given by what? In magnitude it is given by V reference by R. This is in magnitude. So if I write the value of dV, then it will be V reference by R. We care about value only now. We don't care about the equation like sign. V reference by RC into Tx. This should have been Tx. Now actually if you take this point, if you consider this point, at this point dV and dV are the same in both the waveforms. This is dV, this is dV. So both are the same, and therefore we can write equation V reference by RC into Tx is equal to V input by RC into capital T, and you can find out RC get cancelled. and we can write down equation Tx is equal to V input by V reference into T. So, this equation shows us that if input voltage changes, Tx changes, because rest of the things T, V reference are constant, capital T and V reference are constant. V input is the only changing value and therefore Tx changes. So, Tx is proportional to V input, and once you get Tx, it is possible to get a count. Why we can get count from Tx? Because we have this logic, time period plus AND gate, then gated pulses, number of pulses are different for different time period, correct. So, this is the fundamental idea about the dual slope ADC. I think we will stop here, and about the successive approximation we will work in next session.